There's a story that starts with a straight line. For generations, that's how we've lived. Extract, make, use, and discard. It's a line we traced across maps, across oceans, a line we called progress. We built our world on this path, thinking it would last forever. But every line, no matter how long, has an end. I want to tell you a different story, one told in circles. Imagine a monk sitting by a reservoir that once fed a huge textile mill. He remembers when it was full and bright, and he remembers the day the water vanished into pipes, never to return. The people downstream learned to live with less, as if it was their destiny. We were taught to believe in the progress of a straight line, he says. But the world learns in circles. A river doesn't end, it returns. This shift from a line to a circle isn't just about pipes and pumps. It's a total rethink of our purpose. We used to ask, how much can we take? Now, the question is, how little do we need to waste? This changes everything. It means designing infrastructure to return resources, creating policies that reward reuse, and seeing things like water not as a commodity to be used up, but as a shared asset we must protect. For decades, industries were built on convenience, not conservation. Factories used rivers as their personal cooling systems and dumping grounds. The costs of this pollution-choked river's salty soil, struggling communities were ignored. On a balance sheet, it looked clean. In reality, it was a mess. Think about one textile mill in a dry region. It records the cost of water from the meter, the power for the pumps, the chemicals for dye. But what about the downstream farmer whose crops fail, or the fisher who can't find any fish? Their losses never made it onto the ledger. Circularity forces us to widen our view. It asks us to see our industrial world not as isolated factories, but as a living network. The waste from one process becomes the raw material for another. The heat escaping a chimney is captured to power another system. The sludge from a pond is turned into compost for the soil. In this kind of economy, value keeps flowing, risks are shared, and our whole system becomes more resilient, like the roots of a forest. This isn't just a dream, it's already happening. In the Hydroverse archives, there's an old blueprint for a circular water economy. It's more than just a technical drawing. It's a social contract where industries work with rivers and communities, not against them. They create return protocols, promising to give back water that's clean and safe. This isn't charity, it's smart business. Companies that embrace this find their supply chains are less fragile. A food processor that recycles its water is less vulnerable to droughts. A brewery that sends its treated water to a local park builds goodwill and creates a better environment for everyone. These are real advantages that grow over time. The wisdom for this comes from ancient systems, step wells that stored rainwater, canals that carried cool water through deserts, rice terraces that supported both farming and fishing. The lesson is the same. Water was never just owned. It was managed through smart design and community cooperation. The most successful modern projects are built on this same idea: partnerships. Factory managers sitting down with farmers, listening and learning. They discovered that wastewater, when treated properly, can be a valuable asset for cooling systems or irrigating certain crops. The key is matching the quality of the water to the right purpose. Of course, the transition hasn't been perfect. There have been failures. Early projects sometimes mismatched industrial waste with city systems, clogging filters. But we learned from these mistakes. We learned that these connections are delicate and require careful planning and strong agreements to manage risks. Now, we're even creating water credits. A company that saves water can earn credits and sell them to a neighbor, creating a market for conservation. Technology is also a huge part of the solution. New membranes, smart sensors, and low-energy treatments are making it cheaper and easier to close the loop. But tech alone isn't enough. It has to be embedded in a community. The question isn't just how efficient is the machine, but who benefits from it. One of the best examples is a converted industrial park now operating as a circular hub. High-quality water is used for food processing. The slightly lower grade water is used for cooling and landscaping, and the leftover nutrient-rich brine becomes fertilizer for urban greening projects. It took years to build, but the park is now less vulnerable to water shortages. Local biodiversity has increased, and new skilled jobs have been created. This is the real power of circular thinking. It's not just a technical fix. It's a way of building stronger, more connected communities. In a future of hotter summers and unpredictable rain, this is how we build resilience. Systems that circulate resources are less exposed to shocks like droughts or supply chain disruptions. When every drop counts, we are all incentivized to conserve. But we have to be honest. Circularity isn't a magic bullet. It must be paired with fair regulations and inclusive governance to make sure everyone benefits. In the end, moving from the straight line to the circle is a story of learning. It's about industries seeing rivers not as resources to be exploited, but as partners to be respected. The circle isn't about closing an account, it's about opening a conversation. As dawn breaks, the monk holds a cup of water. It's clean and quiet, like a promise. We didn't abandon progress, he says. We redefined it. Progress that returns is not less. It is more just, more resilient, more human. Once industries consumed water without a second thought, treating it as an infinite resource to be used and discarded. But today, something remarkable is happening. A quiet revolution is underway in the heart of our industrial landscapes. Factories are learning to talk to each other, not in words, but in flows. They are exchanging water, energy, and heat, building an invisible web of cooperation that fundamentally reshapes how we think about resources. What was once considered waste is now becoming a valuable asset, shared and reused in a continuous, elegant loop. This is the dawn of industrial symbiosis, where collaboration triumphs over competition, forging a new, sustainable path for our global economy. It's a story not of scarcity, but of ingenuity, vision of a future where industries don't just coexist with nature, but actively work in harmony with it. Our journey begins in Koenborg, Denmark, the birthplace of this revolutionary concept. Decades ago, long before circular economy became a buzzword, a group of companies here pioneered a radical idea. They realized that one factory's waste could be another's treasure. In Koenborg, a refinery's excess steam, instead of being released into the atmosphere, is piped to power a nearby factory. Wastewater from one industrial process becomes the cooling supply for another. For over 40 years, these neighboring facilities, a power plant, a biotech firm, a gypsum producer, and a refinery, have operated in a closed-loop system. They have proven year after year that by working together, they can significantly reduce their environmental footprint, cut costs, and improve efficiency. This isn't just a local success story, it's a blueprint. Koenborg has demonstrated to the world that the sustainable industry of tomorrow is defined not by isolation, but by an intricate, intelligent dance of shared resources. It is a powerful testament to human foresight and a beacon of hope for a circular future. From its origins in Denmark, the concept of industrial symbiosis has spread across the globe, adapting to new climates and challenges. In the arid landscapes of the Middle East and the dense urban environments of Asia, nations are rethinking industrial design from the ground up. Here, in places like Saudi Arabia, the UAE and Singapore's Jurong Island, every single drop of water counts. Futuristic industrial parks rise from the desert and the sea, engineered for maximum efficiency. These aren't just collections of factories. They are integrated ecosystems. Smart facilities are equipped with a vast network of sensors that monitor water quality, usage, and recycling potential in real time. This data creates a living digital map of circular flow, where artificial intelligence directs the movement of treated wastewater from one facility to the next. What was once discharge is now a calculated, valuable input. This global expansion proves that industrial symbiosis isn't a niche concept for a specific region. It's a universal principle, applicable anywhere that resourcefulness and vision are valued. Powering this global shift is a new class of technologies that allows us to see and manage resources with unprecedented precision. Artificial intelligence, the Internet of Things, and digital twins are the invisible engines driving industrial symbiosis forward. A new generation of technologies now tracks the journey of every molecule. AI-driven platforms can analyze vast amounts of data from thousands of sensors, predicting water shortages before they happen and optimizing flows to prevent waste. At the heart of this technological leap is the digital twin, a virtual dynamic replica of an entire industrial park. These simulations model the complete water cycle in real time, allowing engineers to test new strategies, adjust flows, and perfect the system's efficiency without disrupting physical operations. It's a world where advanced nanofiltration membranes purify water to exacting standards, where smart valves open and close with digital commands, and where every component works in concert. This is not science fiction. It is the new reality of industrial engineering, making the circular water economy smarter, faster, and more resilient than ever before. The lessons learned within these industrial parks have profound implications far beyond the factory gates. If industries can learn to share water, so can our cities, our agricultural sectors, and our communities. The principle of symbiosis is universal. It teaches us that waste is a failure of imagination. The future of our planet depends on our ability to see the connections between systems and to design for cooperation instead of consumption. The circular economy begins not in a distant lab, but in every decision to repair, to reuse, and to reimagine what we already have. We are moving from a linear model of take, make, waste to a circular one, where resources are kept in use for as long as possible. The next industrial revolution isn't about producing more, it's about wasting less. As we look toward the horizon, we see a world powered by clean, collaborative industries, where economies and ecosystems thrive together. It's a future built on a simple, powerful truth. Every drop counts. In a world of finite resources, one element connects all life: water. But what if we could see its future? Predict its journey, perfect its every cycle. Before every drop of water moves through a pipe, its path is already known, predicted, tested, perfected. This is the invisible blueprint of water, drawn not with ink, but with data. It's a digital twin, a living replica that mirrors the real world, allowing engineers to model entire water systems in virtual space before a single valve opens. This isn't science fiction. This is the dawn of the circular water economy. A digital twin isn't just a simulation. It's a living model constantly learning from sensors that track flow rates, purity levels, and energy use. Every pipeline, every pump, every filter exists in two worlds at once, the physical and the digital. This dynamic connection allows engineers to test thousands of possibilities before making a single real-world change. Imagine troubleshooting a complex industrial plant without shutting it down, or optimizing an entire city's water grid with a few clicks. From Singapore's pioneering National Water Agency, PUB, to Los Angeles's smart water grid, this technology is already here. It's a revolution happening in plain sight, turning abstract data into tangible efficiency and resilience. At the heart of this transformation is artificial intelligence. AI watches what no human eye can see. It learns patterns invisible to engineers spotting leaks hours before they happen, predicting droughts weeks in advance, and identifying minute impurities in recycled water with pinpoint accuracy. In the age of AI, every molecule of water becomes traceable, its journey from source to use and back again mapped with incredible precision. In these vast digital ecosystems, data particles transform into virtual droplets, flowing through digital pipelines that merge seamlessly into real-world rivers. It's a system that doesn't just react, it predicts, adapts, and evolves. This power isn't limited to a single factory. Entire cities are now adopting this vision. In the new circular cities, water never truly leaves the system. From rainwater on rooftops to condensation from air conditioning, AI tracks and redirects every source, weaving them into a unified, sustainable loop. In Dubai's Smart Water City initiative, digital twins orchestrate supply and demand with unprecedented efficiency. In London, a digital model of the River Thames predicts overflow events, protecting the city from flooding. These cities breathe in data and exhale sustainability, creating a living network where residential, industrial, and agricultural zones are all connected in one digital ecosystem. It is a profound harmony between technology and nature. Ultimately, this story isn't just about technology. It's about the people behind it, the engineers, scientists, and community leaders working toward a shared goal of perfect water recycling through shared intelligence. The next generation of innovators is designing with empathy. Their goal isn't control, it's harmony. A digital twin isn't just a tool. It's a mirror that helps humanity understand how deeply connected we are to every drop, from a single droplet to a global network. Every simulation brings us closer to understanding that water-like intelligence must always flow. What if every pipe in your city could think? Every leak, every drop, predicted before it happens. Welcome to the Internet of HOO, where data flows as freely as water. For centuries, we built water systems to deliver flow. Now, they deliver information. Look at the arteries of a modern megacity at dawn. Beneath the concrete and steel, a network awakens. Pipes, treatment plants, reservoirs pulsing with data. This is the smart water grid, a system where every valve, sensor and pipe communicates in real time, connecting the city like veins in a living organism. We're moving from static systems to living networks. Remember the old infrastructure, rusted pipes, manual meter readings, and reactive maintenance that only addressed problems after they occurred. A burst pipe meant chaos and waste. Today, IoT-enabled systems predict and adapt. A smart sensor detects a subtle pressure change long before a pipe can fail, preventing the disaster altogether. This revolution is driven by dedicated utilities, innovative startups, and pioneering research labs, all building the Internet of HOA. If you could zoom into a single droplet, you'd find it alive with data, a node in a vast intelligent network. Every second, billions of data points flow from smart meters, valves, and even satellites. This torrent of information feeds advanced AI models that predict leaks, forecast consumption, and detect contamination before humans ever notice. We see this in action globally. Singapore's national water grid masterfully balances its resources. Spain employs a sophisticated AI leak detection network, saving billions of gallons. In Israel, agricultural IoT optimizes irrigation, ensuring every drop counts. Imagine a city facing a critical water shortfall. Instead of panic, the AI systems quietly reroute supply, balance the grid, and stabilize the system autonomously. This transformation creates a new generation of professionals. The control rooms of tomorrow are filled with digital twins, holographic overlays, and predictive dashboards. The workforce is evolving. Data scientists, digital plumbers, and AI engineers are the new guardians of our water. As one expert might say, we no longer just fix leaks, we train algorithms to prevent them. An operator wearing augmented reality glasses can adjust water distribution across an entire city with a few simple gestures, orchestrating a complex dance of supply and demand. But how does this grid perform under pressure? Picture a simulated disaster. Flood sensors spike as a storm surges. Rainfall radar shows an unprecedented downpour, putting pipes at risk of overload. In a traditional system, this would spell catastrophe. But here, the AI-driven grid reacts instantly. It diverts excess flow, activates underground storage tanks, and strategically rebalances pressure to prevent major flooding. The Internet of HO isn't just a network. It's an immune system for our cities, protecting them from a changing climate. Expanding our vision, we see this intelligence scaling to a global level. Imagine our planet, seen from space, illuminated by millions of water data nodes. This isn't science fiction. It's the future of planetary collaboration, nations sharing hydrological data in real time to manage resources, predict droughts, and prevent global crises. From the cloud to the ocean, from a single droplet to a universe of data, we are finally learning to listen to water. We are building a future where every drop is counted, protected, and valued. Beneath the surface of our modern world, every industry hides a invisible chemical and essential to its lifeblood. For generations, these rivers have carried away the byproducts of progress, often becoming streams of waste. But what if we've been looking at this all wrong? What if in every polluted drop lies untapped potential? Welcome to Hydroverse, where today we explore the frontier of industrial alchemy. Can industry clean itself? Can the very processes that pollute our waters become the source of their salvation? The answer is a resounding yes. Across the globe, a revolution is underway. Engineers and visionaries are transforming wastewater, the dirty secret of manufacturing, into valuable resources. Clean water, reusable heat, and even energy. This isn't magic. It's the dawn of the circular water economy. Join us as we journey from massive steel mills and textile factories to the microscopic world of biochemical engineering. We'll uncover how advanced systems, monitored by artificial intelligence, are achieving what was once considered impossible: zero liquid discharge. It's a radical reimagining of industrial design, where waste is no longer an endpoint, but a new beginning. The science behind this transformation is as elegant as it is powerful. It begins with understanding the wastewater itself not as a chaotic mess, but as a complex mixture of data. Engineers analyze its chemical signature, mapping every compound and contaminant through advanced molecular processes. Pollutants are not just removed, they are separated, neutralized, and repurposed. This leads to a concept called industrial symbiosis, where one company's waste becomes another's raw material. Take Denmark's Kalundborg Eco-Industrial Park, a pioneering example where factories exchange steam, heat, and treated water in a closed loop. It's a living ecosystem of collaboration, proving that sustainability and profitability can flow together, creating a system that is stronger, cleaner, and more resilient. When we stop treating waste as an enemy and start seeing it as data, industry becomes alchemy. This new mindset is unlocking a wave of biotech innovations. We're seeing specialized algae systems that meticulously capture heavy metals from effluent's membrane bioreactors that reclaim water pure enough for reuse, and electrochemical systems that actually harvest energy from the treatment process itself. The results are stunning. In Belgium, a brewery now recycles over 95% of its processed water, proving that world-class products can be made with a minimal water footprint. In India, textile factories, once notorious for dye pollution, are implementing zero liquid discharge systems, restoring life to once barren rivers. In Taiwan's semiconductor industry, where ultra-pure water is critical, sophisticated closed-loop recovery systems are setting new standards for efficiency. It's not just about cleaning water. It's about measurable results: energy saved, carbon reduced, and ecosystems reborn. And the potential doesn't stop there. Wastewater is no longer just a liability. It's a power source waiting to be tapped. Bioelectrochemical cells and anaerobic digesters are converting organic waste into methane or electricity, turning treatment plants into power plants. These bioreactors pulse like living hearts, feeding clean energy back into the grid and rewriting the energy equation for industry. This monumental shift is driven by the new alchemists of our time, the engineers, chemists, and data scientists working at the intersection of technology and nature. They no longer seek to turn lead into gold. Instead, they seek something far more valuable: balance. They are designing systems where human ingenuity and ecological health are no longer in conflict. From waste to water, from data to wisdom, industry has finally found its philosopher's stone. It is the simple yet profound understanding that in a circular world, nothing is ever truly wasted. Every drop connects us, from the glaciers of the poles to the rivers that flow through our cities. Humanity's survival depends on the harmony of this flow. This is our blueprint for shared survival. Every cloud, every river, every single drop, all connected by invisible threads. This isn't chaos. It's coordination on a planetary scale. The Earth's hydrosphere beats like a living heart, a rhythmic pulse of tides, rainfall, and currents that sustains all life. We are watching the planet breathe, from the swirling ocean gyres to the majestic ice sheets of the poles. This intricate dance is the very essence of our world's circulatory system. Water doesn't recognize our borders. It flows beyond politics, beyond profit, connecting us all in a silent, powerful bond. Think of the great rivers, the Ganges, the Amazon, the Nile, the Colorado. They are lifelines for countless communities, crossing man-made lines on a map as if they were never there. They remind us that we all drink from the same well. This is the truth of our global water commons, a shared planetary resource that demands our shared stewardship. Our survival depends not on ownership, but on cooperation. When we can see water everywhere at once, empathy becomes measurable. We are now entering an age where technology allows us to understand our planet's needs with unprecedented clarity. AI networks visualize rainfall predictions, track pollution in real time, and optimize the flow of desalinated water to where it's needed most. These are not just data points, they are tools for compassion. We can see regions of water stress light up like a global distress signal. And in response, we can create truly equitable redistribution strategies. Imagine you unbacked digital water agreements, guided by objective data, ensuring fairness for all. Picture African nations using cloud mapping AI to build resilience against drought. This is the data of empathy in action. Symbiosis is not just an ideal, it's an engineering principle. Around the world, we see nations proving this by collaborating on shared infrastructure. The Nile Basin Initiative brings countries together to manage their shared river. The European Circular Water Pact redefines how an entire continent uses and reuses water. In the Middle East, vast desalination grids powered by shared solar fields turn scarcity into abundance. These are not isolated projects. They are nodes in a growing global network, connected by a digital twin of Earth's hydrosphere, creating an economy built on cooperation. Nature itself provides the ultimate blueprint. Every living system recycles. Every organism participates in a closed loop. It's time our industries learned from the wisdom of the forest. Coral reefs clean our oceans, wetlands purify our streams, and ancient forests act as natural cloud factories, generating rain for entire continents. From the intricate veins of a leaf to the complex dance of water molecules, nature shows us the path to sustainability. We are now modeling our cities after these biological water cycles, designing systems that work in harmony with the planet, not against it. The blueprint for our shared survival is elegantly simple: share, reuse, respect. Let every drop teach us the pattern of balance. This journey is about more than just managing a resource. It's about realigning ourselves with the fundamental rhythms of life. When we design with water, we design for life itself. Because in the end, we are all part of this one interconnected flow. Thanks for watching. If this vision for a cooperative future resonates with you, please like, share, and subscribe to join our community. Let's continue the conversation together.